Singapore Mathematical Olympiad SMO 2020 Junior Section Round 1. We want to solve all solutions of this year, this section, and I released many sections for many years for round 1, and also I will release other years, other rounds, other sections, and also other Olympiads like Olympiad of USA, AMC, AME, BMO for British Mathematical Olympiad. Also, I will solve some Harvard Mathematics Tournament, Harvard, MIT, Stanford. If you want to have all the problems, all the solution, if you want to improve your problem solving, your math, feel free. If you had any question, feel free to send message to my WhatsApp number in the description and comments. Also, subscribe my YouTube channel and turn on the bell to have next videos. Okay, so let's start. Problem number 1. Problem number 1, multiple choice questions. Let x equals these 2 to the power of 300, y equals 3 to the power of 200, and z equals 6 to the power of 100. Which of the following is true? Now, if we consider these numbers, we should reach the case that the powers are equal. So you can say the first one, x equals 8 to the power of 100, 2 cubed to the power of 100, y equals 9 to the power of 100, and z equals 6 to the power of 100. If we consider this one will be greatest one, y greater than x, x greater than z. So let's check y, x, z. So the answer is D. SMO 2020 Junior Section First Round Problem number 2. An expensive painting was stolen and the police rounded up 5 suspects. Alfred, Boris, Chucky, Dan, and Eddie. These were statements that were recorded. Alfred, either Boris or Dan stole the painting. Boris, I think Dan or Eddie is the guilty party. Chucky, it must be Dan. Dan, Boris and or Eddie did it. Eddie, I am absolutely sure the thief is Alfred. The police knew that only one of the 5 suspects stole the painting and that all 5 were lying who stole the painting. The problem says all of them were lying. So, for example, when Chucky says it must be Dan, we understand that Dan is innocent. So he is okay. And let's check this one. I am absolutely sure that the thief is Alfred. Alfred is because he's lying. So Alfred is okay. He didn't steal the painting. Now let's check the other one. It must be done on. Here it says Boris or Eddie did it. So because he's lying, so both of them are innocent, Boris or Eddie. So we understand Chucky stole and he is guilty one. So the answer is C. SMO 2020 Junior Section First Round Problem number 3. The following diagram shows a system of balances hanging from the ceiling with 3 types of weights. And the balances tip down to the heavier side if we use square less than triangle to represent square is lighter than triangle. Which of the following is true? Okay, so let's write this one: circle by C, 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 triangle by T, circle, circle, and square. So if we consider these 2 terms, 2C will be, let me write from here, 2C is greater than, it's heavier. 2C greater than C plus T. If we consider this part, S plus C is greater than T plus C. And if we consider these 2 terms, 3 on this part is heavier. So T plus 2C plus S is greater than 3C plus T. From first one, if we subtract C from both sides, it will be C greater than T. Here, if we cancel these 2 C, then S is greater than T. Now here, we say 2C, 2C, we can cancel T and 2C subtract. Then we have S greater than C. So we can say S greater than C, C greater than T. So square Is greatest one square greater than circle greater than triangle? So the answer is D. SMO 2020 junior section first round. Problem number 4. The integer 6 has exactly 4 positive factors, namely 1, 2, 3, 6. Likewise, the integer 8 has exactly 4 positive factors, 1, 2, 4, 8. How many integers from 9 to 50 inclusive have exactly 4 positive factors? Okay, so the formula of number of positive divisors, positive factors, if the first number n equals p1 alpha 1 to pk alpha k, the number of positive factors equal to alpha 1 plus 1 to alpha k plus 1. Also, we have formula for sum and product, and they are important also in other SMO problems. If you want to know them or other formulas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Now here you say, okay, it has exactly 4. So 4 can be only 4 or 2 times 2. So in this case, our n will be a p to the power of 3. In this case, it will be p cubed. So if I want to check this from 9 to 50, so I can say p is prime. 2 cubed is not acceptable, so 3 cubed, 4 cubed is not good. So one number here for this one. Suppose p is the smaller one, you can say, okay, if p is 2, then you can say, okay, q is what? Q can be 3. They are different, because if they are same, it will be p squared, and the number of positive factors is not 4. 2, 3, 5, 7, 9, 11, until 25 we should consider, because the product must be, let's say, equal 50. 11, 13, 15, 17, 19, 21, 23. We have these cases. Now, if the smaller one is 3, then you say, okay, it can be 5, 7, 11, 33, 13, 39, 17, 51. It's not possible. If you consider 5, then it can be 7, 35, 11 will be 55. Not possible. And if p, for example, is 7, 7 times 11 is not possible. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But we should, because the problem says it is greater than 9, greater than equal 9 and 50, so 2 times 3 is impossible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the answer is equal to 13. And it will be, let me see, 13. It will be D. SMO 2020 junior section first round. A company sells, problem number 5. A company sells a bottle of juice at $1 per bottle and offers to give you a free bottle of juice if you recycle 4 empty bottles. Assuming there is no limit to the offer and you can recycle bottles that you receive from the offer, what is the largest number of bottles you can eventually consume if you have $43? So here at first, 43, it says what's the largest number of bottles you can eventually consume. So at first you buy 43 bottles. Then you don't have money, you have 43 bottles. Then it says what for give you a free bottle of juice if you recycle 4 empty. So 43 you can use 40 of them, and for 40 you divide by 4, and 3 bottle is left. 40 over 4 is 10. You get 10 bottles, so plus 10, now you have 14 bottles. Now you consider 12 of them you recycle, use, and 12 over 4 you get 2 is left. 12 over 4 is 3. Then you have 5 bottles. Then you say, okay, I consider 4 of them, 1 is left. 4 over 4, and you get 1 bottle. It will be 1 plus 1, 2. You have 2 bottles, then you can't get any more. So it will be what? It will be 43 plus 10 plus 3 plus 1. and it is equal to 43 plus 10, 53, 56, 57. So the answer is E. SMO 2020 Junior Section First Round Short Questions. Problem number 6. Let n be a positive integer. Suppose the lowest common multiple of 4, 5, and n is 2020. What's the sum of the smallest possible value of n and the largest possible value of n? So here we know LCM of 4 is 2 squared, 5, 20, 20 is 10, 10, 2, 5. 2 here, 2 squared. If you prime factorize, it will be 5 times 101. It says lowest common multiple. Oh, sorry. It is for the answer. The answer is this. So let me take it here. Take it here. Okay. 2, 4, 5, and n equals this. So n, let's see, can have 2 to the power of alpha. 5 can have 5 beta, and 101. It should have 101 to the power of gamma. Because it is 2 squared, we have 2 squared, so alpha is at most 2. 5 to the power of 1, we have 1. Beta is at most 1. And gamma, we don't have 101, the power is 1, so 100 equals 1. Gamma equals 1. Now, the maximum, it says what's the sum of maximum plus minimum case. Maximum is 2 squared, 5 to the power of 1, 101 to the power of 1 plus minimum. Alpha 0, beta 0, and 101. So it will be 4 times 520 times 101 plus 101. So it will be what? It will be 2020 plus 101. It will be 1212. So the answer is equal to 2121. SMO 2020 Junior Section First Round Problem number 7. When the 5-digit integer 2x65x is divided by the 4-digit integer 5y227, the quotient is 4 and remainder is x106, which is a 4-digit integer, this number. What is the value of the digit x? Let's write when we divide, it will be 2x. If I want to write, it will be 2, 1, 2, 3, 4, 40 plus 1000x plus 600 plus 10y plus x is divided by this 4-digit number will be 27 plus 100y plus 5000. The quotient is 4 and the remainder is this. It will be 106 plus 1000x. Now if we simplify, let's see what we have. For the x, we have 1000 plus 1. Here we don't have minus 1000x. Plus y here, we have 10 minus 400. And it is equal to what? 27 times 4 plus this times 4 plus this. Let me underline the constants. This one, this. Now let's calculate. 4 times this, 4 times 7, 28. We have 2, 4 times 2, 8 plus 2, 10, 108 plus 20,000 plus 106. Here, if you take to the right hand side, minus 20,000 minus 600. So we can cancel these two terms. We can cancel these two terms. It will be x minus 390y equals 108 minus 60. It will be negative this minus this. 10 minus 8 is 2. 9 minus 0 is 9. And 5 minus 1 is 4. Let's check it again. Yes. Okay, it is this. Now you add by plus 106. So it will be minus this minus 12 minus 6, 6. 8 minus 0, 8. And 4 minus 1, 3. So x and y are digits. We can multiply both sides by negative 1. 390 y minus x equals 386. So because x and y can be only between 0 to 9, and it is 4-digit number, so x is not 0. So the only possible case is y equals 1 and x equals 4. So the answer, the x, the problem says what's the value of the digit x. The answer is equal to 6. Sorry. The answer is equal to, here I've written x4. The answer is equal to 4. SMO 2020 Junior Section First Round Problem number 8. How many multiples of 11 are there in the sequence here? Okay, when we want to solve these types of problems, for example, maybe remainder 2, you write like this. 11k, for example, if the remainder when divided by 11 was 2, you write 11k plus 2. You write greater than equal 1100 and less than or equal 2020. You divide by 11, it will be 100, yes, and the next one will be this one. 1 times 11 is 9, 9 is left, 92, 8, 88, 40, 43 point some decimal numbers. So because k is integer, it is less than or equal floor of that 183, this 100. So the answer is equal to 183 minus 100 plus 1, which equals 84. So the answer, the multiples of 11 in this sequence is equal. SMO 2020 Junior Section First Round, problem number 9. A quadruple ABCD of positive integers is skewed if the median and mod of ABCD are equal but strictly greater than the mean of ABCD. How many skewed ABCD of positive integers are there that satisfy A is less than or equal, B less than or equal, C less than or equal D, and A plus B plus C plus D equals 40? Because we have mod, we have one element that comes at least twice. So we don't have element that comes 4, means A is all of them are not equal, then we don't have mod. So the first case, suppose that 3 of them are equal and 1 of them is different. It is case 1. So in this case, let's consider median is what? Median is x. It is not important x is greater than y or x less than y. It is this, and we know x is not equal to y. Median is x. Mod is also equals to x, and is strictly greater than mean. It is 3x plus y over 4. So it is equivalent that 4x is greater than 3x plus y, and is equivalent that x is greater than y. So we have what? Y is smaller than x, and we have again x and x. Also here, a plus b plus c plus d equals 40. So we can say 3x plus y equals 40. Y is less than this, so it's 3x. Let's consider the case x is at most 13. So it is 13, it is 1, it is 12, it is 4, it is 11, it is 7, it is 10, it is 10, and we know it's not possible because x is greater, strictly greater than y. So here we have 1 answer, 2 answer, and 3 answers we have here. Now let's consider second case. In second case we have 2 like this, x, y, and z. So here mod is x, and look, if for example y and z both of them are less than x, then here we know y is not equal to z, because if y equals z we don't have mod, and x is not equal to y, x is not equal to z. If y and z both of them are less than x, the problem says what? Mod is equal to, let me see, mod is equal to a median is strictly greater than mean. So mod is equal to median strictly greater than mean. So here in this case it is bad, because in this case mod is what is x, but median is not x. For example, it's x plus z over 2 or x plus y over 2, and they are not equal. So this case is bad. Also if you have similarly x, y, z, it is bad. So we can say one of them is less than this, one of them is greater than this. Without loss of generality, y is less than x, x is less than z. Now here, mod is what x, median is what x, it's greater than mean. So x plus 2x plus y plus z over 4. So 4x, you can simplify 2x is greater than y plus z. And we know what? We know 2x plus y plus z equals 40. Here we can say, okay, y plus z is what? Is 40 minus 2x. And then we can say, okay, we conclude that 4x, take negative 2x to right side, left side. 4x is greater than 40, so x is greater than 10, and it is equivalent that x is integer, x is at least 11. So let's check. Now let me copy this one, Control C, Control V. And we know y is less than x, less than z. So x is greater than equal 11. The first one. If x is 11, then y plus z equals 40 minus 2 times 11 minus 22, which equals 18. So y is less than that. So here we can say, okay, yz can be 1. Y is less than that. Y is 17. But look here, one case is 117, okay? Okay, the next case is 2. You can say 216. And next case 315, 414, 513, and 612. Okay, we've written all the cases and we see that y is less than x, less than z in all these 6, 1, 2, 3, 4, 5, 6 cases. So 6 cases we have here. If x is 12, 2x plus y plus z is 40. If x is 12, then you can say y plus z equals 40 minus 2 times 12 minus 24, which equals 16. Now, we know z is greater than x, so z 13, y 3, 14, 2, and 15, 1. So here we have 3 different cases. The next one, you say 2x plus y plus z equals 40. X is 13. So you say y plus z equals 40 minus 2 times 13 minus 26, which equals 14. Y must be greater than 13. Z must be greater than 13. So it's 14 and it's 0. And there are integers, positive integers, so it's bad. And for other cases, you can see they are impossible. So we have 3 cases here, 6 cases here, 9. And also we have 3 cases here, 9 plus 3, 12. So the answer is equal to 12. SMO 2020 Junior Section First Round, problem number 10. Let Tn be a linear sequence given by T110, T213, T316, and Sn be a quadratic sequence given by S110, S223, S139, and so on. What's the value of S101 minus T101? So when we have a linear sequence, it means that it is, for example, an plus b. So if, for example, the first one, 10, it is what? A plus b. It is what? 2a plus b. So if we subtract T2 minus T1 is 3, and this minus this, B will be cancelled, will be A. So A is 3. And from first one, you say, okay, A is 3, 3 plus what is 10? B is 10 minus 3, 7. And you can check, it will be what? 7 plus 2 times this, 6, 13, 7 plus 3 times that. So we found the first sequence is 3n plus B. Now for this one, you say, okay, S1 is 10, S2 is 23, S3 is 39. Here you say, okay, it is Cn squared plus Dn because it is quadratic sequence plus E. So if you write this one, it will be C for 1 plus D plus E. This one will be what? 4C plus 2D plus E. And this one will be what? 9C plus 3D plus E. If we subtract these two terms, it will be 3C plus D. If we subtract these two terms, we will have what? And it is what? 23 minus 10, which is 13. And this minus this, which will be 5c plus d. 39 minus 23 will be 60. And if we again subtract this minus this, it will be 2c, it will be 3. So c equals 3 over 2. And if we replace here, for example, for this one, here we have 9 over 2 plus d is 13. So d is 13 minus this, use common denominator. It will be minus 9. It will be 16 minus 9, 7. It will be 17 over 2. And we should find c. c plus d plus e is 10. c plus d is what? Is 20 over 2, 10. 10 plus c equals 10 plus e. c plus d is 20 over 2, 10 plus e equals 10. So we conclude e is 0, and here it will be what? 3 over 2n squared plus d is what? 17 over 2n, and e is 0. Now we say, okay, S101 minus T101. Here it is S101, it is 3 over 2 101 squared plus 17 over 2 101 minus T101. Here T101 is 3 times n plus b, here 3n plus 7. So it will be minus 3 101 plus 7, negative plus 7 will be negative 7. So here we can factor from 101 for these three terms. 101, it will be 303 over 2, it will be 17 over 2, and here it will be negative 3 minus 7. Now, if we add up these two terms, 101, 7 plus 3, 10, we have 1, it will be 2, and it will be 2 over 2 minus 3 minus 7. If we divide, it will be 160, it will be 101 times 157 minus 7. Now we multiply these two numbers, 157, 101, it will be 157, and 751, 75851 minus 7, it will be equal to 15850. So the answer is 15,850. SMO 2020 Junior Section First Round, problem number 11. Let ABC be a triangle where D is the midpoint of BC, so this BD equals DC, and E lies on AC such that AE over EC 3 over 1, so we call 3x this one and x. Let F be the intersection of AD and BE. F. If the area of ABC is 2AD, what is the area of triangle BFD, this one? Okay, so let's call this area Y. If I draw this F, connect F to C, then it is also Y, this area. Now, if this area is W, because it is X, it is 3X, it will be 3W, and because this midpoint, the whole part here is equal to whole part here. If we subtract y from both sides, 3w plus w, it will be 4w. And we can say that if we consider ABE, it is 3 times BEC. So ABE is what? AB is 4w plus 3w. It's 3 times this part, 2y plus w, which equals 6y plus 3w. If we cancel these two parts and divide both sides by 2, 2w equals 3y. Now, the area of ABC is what? Is 2AD. The area of ABC is 2y plus 48w. We want to find y, so we can write w in terms of y. So it will be 2y, 2w is this. We want aw, we multiply both sides by 4, so plus 12w equals 280 So 14y equals 280. If we divide both sides by 14, then y equals 20. So the area of BDF, which is y, equals 20. SMO 2020 Junior Section First Round, problem number 12. In the figure below, each distinct letter represents a unique distinct digit such that the arithmetic holds. If the letter K represents 6, what number does shake represent? We have a lot of these types of problem in SMO, so let's replace. K is 6, so K here is 6, and all of them, for example, K and A, they are different. And here E. So if E0 is possible, 1 here, 2 impossible, 2, 4, 3, 6. If we have 4, 8, 5, 10, 6, 12, 2, 7, 4, 8, 6, 9, 8. So the only possible case is E 0, 0, 0. And 6 plus 6 is 12, so L is 2. And we have 1 here. So here we conclude 2a plus 1 mod 10, the ones digit is t. So t is odd. T is odd. And because t is odd, here h we have carrier here. So, and carrier here cannot be 2 from this part, so we should carry 1 here. So here we can say, okay, 2a plus 1 is, because we have 1 here, is 10 plus t. Now 2h plus 1, it is not 10. We don't have carrier here, because if we place 1, then if it is 10 plus t, then a equals h. So it is equal to exactly t. And here we don't have carrier, so 2s we have here, and mod 10, ones digit will be a, so a is even. We conclude a is even. And because the digits are not equal, we have e is 0, so r here, we have at most 1 here, because ss, at most 9, 9, 18, we have 1. So r is 1. Now here, let's see what digit we've used so far. 0, 1 here, 1 for r. And it's for e, it's for r. Then k is 6, we've used, and L is 2. We've used these digits. Now, A, I've proved that A is even, and 2A plus 1 is 10 plus C. It has carrier. So A is at least 5, because 4 plus 1 is 9. We don't have carrier here. So A is at least 5. A is also even. So the minimum case A can be 6, but 6 is K. So we should consider only 8. And so A is 8. The only case that we have for A is 8. Let me write this part. It is 8. Let me write a little better. It is 8. This one is 8. So 8 plus 8, 16 plus 1, 17. So T is 7. And here is 7. 2H plus 1 is T. So H is 3. This 3. Here we have 8. So S is what? Is 4. 4. We found all the digits. Now, if we consider shake, S is what? S is 4. H is what? Is 3. A is what? Is 8. K is what? 6. 0. So, let me correct some part. Because we have carrier here, 1. Okay, so we should correct this part. Let me correct this part. Okay, so for S, it must be 18. 2S must be 18. So S is 9. And S here is 9. So it will be 93,860. SMO 2020 Junior Section First Round, problem number 13. The diagram below shows a shape formed from 4 semicircles whose radii are distinct integers. So for example, this one is R1, R2, radius, R3, and radius of the whole shape is R4. If the shape has perimeter of 18 pi. So here, at first, let me tell you something. R1, the diameter of this one plus this one plus this one equals diameter of the fourth circle, so we can say 2r2 plus 2r1 plus 2r3 equals 2r4, so we can conclude we can rearrange r1 plus r2 plus r3 equals r4, and the perimeter, if the shape has perimeter of 18 pi, so perimeter is this circle. We know for circle perimeter is equal to r 2 pi r, and area is pi r squared. So perimeter of this shape will be this one, and it is semicircle, so it will be, instead of 2 pi r, it will be pi r4, and this one, this one, this one is perimeter, plus pi r2 plus pi r1 plus pi r3 equals 18 pi. We can cancel, we can divide both sides by pi. So we conclude r4 plus r1 plus r2 plus r3 equals 18. So it is, this equals to this, so we can conclude it is 9. The next condition is, and encloses an area of k, pi k is prime. What is the value of k? So this area is, as we said, this is pi r squared, the whole area. It is semicircle, so it will be pi over 2 r4 squared. It will be the whole area here, so you should subtract minus r2 squared minus r1 squared minus r3 squared. It equals k pi, which k is prime. So let's simplify. We can cancel pi from both sides, and we know r4 is what? R4 is 9. I'm sorry, here we should place squared r3 squared here. Now we say okay. If we replace, if we can say it's 2k. Also, you can write r4 is what? R4 is r1 plus r2 plus r3. If you raise to power of 2, we have r1 squared, r2 squared, r3 squared. It will be cancelled. And we have 2r1 r2 plus 2r1 r3 plus 2r2 r3. So we can divide both sides by 2. r1 r2 plus r1 r3 plus r2 r3 equals k, and r1 plus r2 plus r3 equals 9, and k is prime. So we consider maximum one or 3. We consider different cases. It can be, because they are integer, it cannot be 8 or 9 because we don't have 0. So it is 7, maximum number of R3 is 7. 6, then we have 2, 1, only this case, 5. Then some of other case will be 4, it will be 3, 1, 5. Because they are distinct, they are not equal. The problem says they are distinct. Let me show you. Distinct. So 5, 2, 2 we don't have. If you have 4, then they are distinct. They are less than 4. So 3 and 2, if you replace 3, 2, it will be the last case. And for 3 we don't have, because 3, 2, 1 is not possible. So let's check for this one. K is what? 1 times 1, 1, plus 1 times 7, 7, plus 1 times 7, 7. It will be 15, and contradiction because K is prime. For this one, K is 1 times 2, 2, plus 6, plus 12, which will be 20, and contradiction, this one. K is 1 times 3, 3, plus 1 times 5, 5, plus 3 times 5, 15. It will be 23, and for this case, K equals 2 times 3, 6, 2 times 4, 8, plus 3 times 4, 12, and it's 26. So the only possible case is this one. So the answer, the problem says K is what? K equals 23. SMO 2020 junior section first round problem number 14. If the sum of the two diagonals of a kite is 100, what is the largest possible area of the kite? Okay, so here the sum of two diagonals AC plus BD is equal to 100. Area of ABCD, area of any quadrilateral is sum of 1/2 product of diagonals times sine alpha. Here, for example, the angle between the diagonals. Here is 90, sine 90 is 1. So it will be AC times BD over 2. We want to maximize ACBD over 2. If we use AMGM, then you can say, okay, ACBD, its GM is less than or equal AC plus BD over 2, which will be 50. And equality happens when AC equals BD. So AC times BD is less than, if you raise both sides to the power of 2, it will be 2. Both sides are positive. You can raise, it will be this. And if you consider over 2, it will be this. 1, 2, 50. And the case happens when AC equals BD equals 50. And it's a rhombus. So the area of this kite equals 1250. SMO 2020 junior section first round problem number 15. What's the smallest 5-digit integer of the form 5x20y that is divisible by 33? Okay, divisible by 33 means is equivalent to divisible by 3 and 11. So for 3 you say, okay, 5 plus x plus 2 plus 0 plus y is multiple of 3. So mod, let me write like this, mod 3 is congruent to 0. 5 plus 2 is 7. 7 mod 3 is 1. So 1 plus x plus y is 0. And you can say, okay, it means that x plus y is congruent to -1 or 2 mod 3, also mod 3 here. Now for 11, you say, okay, the formula for considering 11 is like this. You start from y, you say y minus 0 plus minus alternatively y minus 0. If you want to know the reason and also knowing for other divisibilities, feel free, as I said before, send message to my WhatsApp number in the description and comments. Plus 5 is congruent to 0 mod 11. So let's check it again. Y minus 0 plus 2 minus x plus 5. Okay, so 5 is y minus x. 5 plus 2 is 7, so -7 here. 11 minus 7 will be 4. It will be mod 11. Because y and x are digits, and digits, y minus x can be equal to 4, or 11 plus 4, 15 is impossible, or 4 minus 11, -7. For example, y 0 x 7 is possible. For this one, x plus y can be 2 or 5 or 8, 11, 14, 17, 20 is impossible. So let's consider at first case 1, y minus x equals 4. So it can be 4, 0. 4 plus 0 mod 3 is not 2. So it is bad. So we should consider mod 3 must be 2, some of them. It can be 5, 1, 5 plus 1, 6 is not. 2 mod 3, 6 plus 2, you can check this. 7, 3, some of them 10, it's bad. 8, 4, some of them is 12. 9, 5, some of them is 14, mod 3 is 2. So we have these two numbers. And case 2, you consider y minus x is -7. So you say it is 0, it is what? 7. It is 1, it is 8. It is 2, it is 9. So some of them here is 1 mod 3, it's bad. 1 plus 8, 9, multiple 3 is bad. 2, 9, it's good. You should check these 3 cases. This one, this one, this one. Now, the problem says what? Find the smallest 5-digit number. 5x20y, 5x20y. So, because we want to find smallest, x should be minimized. X here is 9, it's bad. 2, 5. So, this case is good. X is 2. Y is what? Y is 6. So, the answer will be 52, 26. So, the answer is equal to this number, 52,206. SMO 2020 junior section first round problem number 16. What is the value of 2020 cubed minus 9 times 2020 times 2017 minus 2017 cubed? Okay, we know that a cubed minus b cubed, you can factorize like this. For general n, it has a formula, and for plus, for n odd, we have formula. It will be a squared plus b squared. Now, if we use for these two numbers, 2020 minus 2017 will be 3 times 2020 squared plus 2020 times 2017 plus 2017 squared minus 9 2020 times 2017. 3 times this minus 9 times this will be minus 6. So it will be 3 2020 squared minus 6. You can factor from 3. You can say minus 2 times 2020 times 2017 plus 2017 squared. And you can say, okay, it is a squared minus 2ab plus b squared. So you can say it's 3 2020 minus 2017 all squared. It will be 3 times 3 squared, which will be 3 times 9, which equals 27. SMO 2020 Junior Section First Round, problem number 17. In the following diagram, ABCD is a rectangle where E and F are points on B, C, and C, D. It is D. Respectively, the area of triangle AEF, denoted by this, is 2037. Area of AECF. AECF is twice ABE, and it's 3ADF. So 3ADF. So if I call this one 2x, so it will be 6x. So here it will be 3x, and AECF will be 6x. So this area will be 6x minus, let me write it outside, 6s to have enough space. Okay, it will be this. Now the problem says what's the area of the triangle A of rectangle ABCD. So if I want to find area of ABCD, I can say, okay, it is 2x, 3x, 2x plus 3x, and this part is 6x plus 6x, which equals 11x. So, for example, here you can say, okay, we know if we draw AC, then the area of, let me draw, and this one, I know this part is half of area. It will be 11x over 2, 11x over 2. So here, ABE, area of ABE, over area of ABC, half of the rectangle, equals what? Equals BE over, because the altitude is same, so it's ratio of bases, BE over BC. ABE is what? 3x. ABC is what? 11x over 2. We can cancel these two things. It will be 6 over 11. Now I say, okay, BE over BC minus BE, which is CE, equals 6, 11 minus 6, which will be 6 over 5. So BE will be 6, 5. EC will be 5y. Now, it is for this part. Here, we do the same thing for finding the ratio here, DFFC. We say area of ADF over area of ADC is equal to, ADF is what? 2x over 11x over 2. If we divide, it will be 4 over 11. ADF is, you can say it will be bases. DF, if you consider these two things, it will be this over this, the ratio of bases, because altitudes are same. It will be DF over DC. And these types of problem relating areas to ratios is useful in Singapore Mathematical Olympiad, Hong Kong, and other countries. If you had any question, wanted more problems, more ideas, as I said, feel free to send message to my WhatsApp number in the description and comments. So here we say, okay, df over dc minus df equals 4 over 11 minus 4. dc minus df is fc. So it will be 4 over what? 4 over 7. So you can say df is 4w, and this length is 7w. Okay, now we can say the area of triangle, the area of rectangle is 11x. We've counted here. Also, you can say, okay, this length is 11w, 4w plus 7w times this length, which will be 6, 5 plus 5y. So it will be 11w times 11y. You can cancel these two w's. It will be x equals 11wy. Now, we found these two terms. This area is 6x minus what? 6x minus 2237. It equals this times this rectangle. 7w times 5y all over 2. Now we want to use this, so it will be 35wy over 2. Now we multiply both sides by 22. It will be 22 times 6x minus 2037 times 22 equals 35 times 11wy. 11wy is x, so it will be 35x. Now we found an equation and one variable x. So if we calculate, it will be 6 times 2, 12. We have 1. 6 times 12 plus 1, 132. So 132x minus 35x. 12 minus 5, 7. And it will be 2. 12 minus 3 will be 9. So it will be this equals 22 times 20, 37. So x equals 22 times 20, 37 over 97. If we divide these two terms, it will be 2 times this, it will be 14, 194. We have 6, 3, 9, 97. 97, then you say 21. So the answer is equal to 21 times 22. If I calculate that, it will be 2, 4, 2, 4. And it will be 2, 6, 4. Okay, so x is this. The problem wants what? The problem wants what's the area of rectangle? We found is 11 times x. So if we multiply 462 by 11, then we have 264, 264. It is equal to 2, 8, 10, 5. So the answer of the problem equals 50. SMO 2020 Junior Section First Round, problem number 18. In the following diagram, ABCD is a square of side length 64. Okay, so the length is 64. You can write here because it's square. Is the midpoint of AB, so it is 32. 32F is the midpoint of EC. Okay, so these two things are equal. And what is the area enclosed by the quadrilateral AEFG? Okay, we consider this is A1. We want to find A1. It is A2. It is A3. It's A4. So the first one, A4, is so much easy because A4 right angle triangle is 32 times 64 over 2, which will be 2, 32 squared, 2 to the power of 5 squared, 2 to the power of 10. It equals 1024. Now we focus on finding 3. If I want to find 3, let me show you here. Or let me draw with this. And okay, so if I want to find for A3, I say okay, it is A3 and this one. Okay. So it is what? It is 32. 32. It is equal to A4. So if I want to find A3, I say what? I say if I subtract these two areas from the whole circle, it will be 64 squared minus 2 times this, 2 times 1024. It will be the whole part. It is half of that. It is over 2. So it will be 2 to the power of 6 squared, 2 to the power of 12 over 2, 2 to the power of 11 minus 2 to the power of 11 over 2 minus 2 to the power of 10, which will be 2 to the power of 10, which will be 1024. Now, to find A1, for finding A1, I can say, okay, if I draw this line, let me show with pink. A1 is sum of these two areas. Let me call the first one, for example, B1, B2. So A1 is what? Is B1 plus B2. Because it is midpoint here, B1 is half of AF area AFD. B2 is, if you draw this area, let me draw it with green. If we draw this one, it is median. So B2 is half of, show B2 is half of area AEC. So if we want to find area of AEC, if you consider this triangle, I mean, AEC is equal to A4 because it is median. It is midpoint 3, 4, 1, 2, 3, 4. It's midpoint, so it is equal to A4. It is equal to 1, 10, 24. Now we should focus on finding AFD. If I want to find AFD, I say, okay, it is equal to whole area 64 squared minus here A3 minus A4 minus AEF. AEF is what? Half of AEC. Minus half of AEC. So it will be 64, 2 to the power of 6 squared, 2 to the power of 12, 4096 minus 1024 minus 1024 minus half of AEC. Minus 512. Now it will be equal. These two things will be 2048. This minus this will be 2048. So minus 512, it will be 6. 4 minus 1, 3. 10 minus 5, 5. And it will be 1536. Now, if I calculate this part, AFD over 2, which will be this over 2, 7, 13, 6, 16, 8, plus AEC over 2, which will be 5, 12. It will be 10, 1, 1 plus 6, 7, 8, 7 plus 5, 12. So the answer is equal to 12. SMO 2020 Junior Section First Round Problem number 19. Let x equals 1, 2, 3, 4, 2, 78, 79, 80, 81. The problem says be the integer that consists of all the integers from 1 to 81. Return from left to right what is the remainder of x when divided by 2020. Okay, when we want to find x, the remainder when divided mod 2020, if we prime factorize 2020, 10 is 2, 5, and 202 is 2 times 101, so it is 2 squared times 5 times 101. So it is equivalent to find x, the remainder of x when divided by mod 2 squared 4, mod 5, and mod 101. So the first one is easy. 4, consider the last two digits. X mod 4, the last two digits 81 is 1. If you consider x mod 5, it is 1. X mod 101. So for considering mod 101, you can say, okay, if you have a digit an minus 1, an minus 2, to a, for example, 6, a5, a4, a3, a2, a1, a0. If you consider a number with n plus 1 digits, mod 100, you can say, okay, it is a1, a0 plus a3, a2 times 100. And then you say, okay, it is plus a5, a4 times 100 squared, and so on. If you consider this mod 101, because 100 is negative 1, it will be a1, a0 minus a3, a2 plus a5, a4 minus a7, a6, and so on. So if I want to consider this number, mod 101, it will be what? You say, okay, it will be 81 minus 80 plus 79 minus 78, and you consider until 10. Look, odd minus even, odd minus even. It will be plus 11 minus 10, but the rest of the numbers will be 1 to 9. So if you consider 1, 2, 3, 4, 5, 6, 7, 8, 9, for example, 10. So until here we consider minus, so 89 plus 89, the next number, minus 67, plus 45, minus 23, plus 1. And here we say, okay, it is 1, and here it's 1. How many 1 do we have? 80 to 10, and divided by 2, so 80 minus 10 over 2 plus 1. If you have, for example, arithmetic sequence, if you want to find the number, last one minus first one over 2 here. Because each one is added by 2, this one. 89 minus this will be 2. 8 minus 6, 22. Here it will be 2. 2. So 22 plus 22 plus 1, 45. So it will be 45. And it will be 70, 35 over 35 plus 45 equals 80. Sorry, here I said last one minus first one over 2 plus 1. You should add plus 1 also here. So plus 1 and plus 1, which will be 81. So now we know x is here. If I replace now 81. So you can write 81 also for this one, 81 for this one. So we can say, okay, x mod 2020 equals 81 is for all of them. X minus 81 is multiple of 4, 5, 101. So multiple of LCM of them. So it will be 81. When you reach same number, it's same number you can write for LCM of them. So the answer is equal to 80. SMO 2020 junior section first round problem number 20. Let a equals 1 over 7 times this number, where this number is the rational number with recurring digits 1, 5. In other words, it is this. Okay, suppose that a equals m over n when where m and n are positive integers with no common factors larger than 1, which is the value of m plus n. Okay, so let's consider this number b. So you say b is what? 3.1. Let me write it better. 3.14151515. So if we multiply 100b, then we have 314.1515. And then if I multiply it by 10,000b, then I have 31415.1515. If I subtract 10,000 minus 100 will be 9,900b equals 3141.5 minus 314. 5 minus 4, 1. 1 minus 1, 0. 4 minus 3, 1. And 1 and 3. So b equals what? Equals 3110199900. And a is what? A is 1 over 7 times b, which is 9900. 31101. Okay, so let's simplify. If we simplify here, it's multiple of 3, it will be 3300. Here it will be 1, 0, 3, 26, 21, 7. Now, if we consider this, is it multiple of 3? It's not multiple of 3 anymore. Is it multiple of 2? No. Is it multiple of 11? If you consider plus, minus, plus, minus, plus. So 7 minus 6, 1. 1 plus 3, 4. 4 plus 1, 5. So it is not multiple of 11. So you can't simplify with this denominator anymore. For 7, 1, 7, 33, 4, 56. Yes, it's multiple of 7. You say, if you divide it by 7, 133 4 times, 28, 56, 8, and 1. So the answer is equal to 1481 over 3300. The problem, it is m, it is n. You can't simplify anymore. No common factor larger than 1. The problem says m plus n is what? So 1 plus 0 is 1, 8 plus 0 is 8, 4 plus 3 is 7, 1 plus 3 is 4. So the answer is equal to 4781. SMO 2020, junior section, first round, problem number 21. Ali and Barry went running on a standard 400-meter track. Okay, they started simultaneously at the same location on the track but ran in opposite directions. Coincidentally, after 24 minutes, they ended at the same location where they started. Ali completed 12 rounds of the track in those for 24 minutes, while Barry completed 10 rounds. How many times did Ali and Barry pass each other during the run? Exclude from your answer the times that they met at the start of the start of the run, and when they completed the run after 20 minutes. For solving these types of problem without loss of generality, suppose that Ali runs clockwise, for example, if you see from top, and Barry runs counterclockwise. So here for these types of problem, you can say, okay, we want to find A and B in terms of each other. Consider B doesn't run and only A runs. So instead of 12 and how many? 12 and 10. So for example, it has 24 rounds, 0 round. So here also in speed, this idea is so much useful. Also in speeds, here we don't need speed and 24 minutes. We want to calculate the number of terms they runs the whole circle, and it will be 12 plus 10 will be 22 rounds. First time he sees, okay, so he rounds 1 in the first, so 0 is impossible when he's here. In the first round he sees this again. In second round, 21 first round, and here all of them are okay. In 22nd round, they reach each other for the last time and says, okay, after 20 minutes, you shouldn't count that. So the answer of this problem equals 21. SMO 2020, junior section, first round, problem number 22. If we have this term, this equality, for some integers a0 to a100, what is the value of this term? Okay, so this term equals this. So consider, for example, this is f of x or p of x. If I want to find a0 plus a1, a0 is we don't have, but if we consider p of 1 over 3, then we have a0 plus a1 over 3 plus a2 over 9 plus 2 a100 over 3 to the power of 100. Also, if you replace 1 over 3 here, it will be 0, 1 minus 1, 1 minus 1, 0 plus 0, it will be 0. Now, because we want to find absolute value of this, we should find a0. We know p of 0 equals, if you replace x with 0 here, equals a0, and it equals, if you replace 0, x with 0, all of them will be 1, and we have 100. So this term, it is 100, so this term equals negative 100, so absolute value of that equals 100. SMO 2020, junior section, first round, problem number 23. What is the value of this term? So consider this term equals x, then consider x squared is 27 minus this, 27 plus this will be 54, plus 2 times 27 squared, which will be 729, is 3 to the power of 6, minus 704, it will be 54, plus 2 times, here it's 525, 2 times 5, it will be 10, 54 plus 10, 64, so x, absolute value of x is 8, but here we know it's positive 2 square roots, some of them, so x equals 8, and the answer of this problem is equal to 8. SMO 2020, junior section, first round, problem number 24. If m is greater than n, are positive integers satisfying this equality? What is the smallest possible value of mn? Okay, for this problem, you can take 1 to left hand side and then factorize. It will be m squared minus n squared minus 1. M squared minus n squared plus 1 equals adn. So there are positive integers, so it's positive. And here we can say both of them are positive or negative because m is greater than n, so it is positive. It is positive, we are sure. It must be also be positive. Now you say, okay, this one is greater than this one. So if I consider the cases, it is the smallest case, ADN, one of them contains n. So if I consider it is 1, then it will be ADN. If I consider 2 here, it will be 40n. If I consider, okay, let's consider 80 is what? 80 is 2 to the power of 4 times 3. And we can say we have 10, around 10 positive divisors. And here their parity must be same. Because look, if we consider m squared n squared minus 1, the sign is not important. So for example, this case is bad because odd, it is even. So you can say it can be 240n or 420n. Sorry, here is 3, it's 5. And if you consider 5, 16n, odd, even, impossible. 6, 7, 8, if it is 8, it will be 10n. If here we have 10, then it will be what? It will be, because it is even, it must be even times even. So it will be 10, and here it will be 10 times 8. Okay, 8n. Also, we consider, okay, 8, 10. The next one is 16. Let me write here 16, 5n. Okay, we've checked 1, 2, 3, 4, 5, 6. 2, 4, 6, 5 we've ignored. And 7. So 3 cases are left. 20 and 24n. 40. 2n and 80n. So also you can say 180n or 80n1, for example, 240n. We consider both cases for each of them. So from the first one, let me write the rest of that with green. Here m squared minus n squared, if this is 2, is 3, or if this is 2, it will be 1. Now we know m and n are positive integers, so if you consider squares, it will be 1, 4, the next one 9, the next one 16, the next one 25. So if you consider 1 minus 4, 4 minus 1 is 3. So the only case is that it is 2 squared minus 1 squared is, for 1 we don't have any case. Here 2 squared minus 1 squared, if we replace this part, it will be 2 squared minus 1 squared, 3 plus 1 is 40. So here we know it must be at least 40, and it's contradiction. Here m squared minus n squared is what? If here you have also for the other case it's contradiction. Let me tell you, for example, 4 m squared minus n squared, if this one is 4, so it will be 5, and then m squared minus n squared plus 1 will be 6. But here it is at least 20. So we reach contradiction for this part, also this part. Also, if you consider for this one, it is 4, then it is 20, and with similar way, you will reach contradiction. Here, we say m squared minus n squared is minus 1 is 8, so plus 1 is 10. So if we have this case, only n should be equal to 1, and m squared minus 1 minus 1 minus 2 is 8, again contradiction. If here is 10, it is 8, so 10, and again contradiction for this part. M squared minus n squared is what? Is 1 plus 10, 11. So if we consider m squared minus n squared plus 1, it will be 12. 12 is not multiple of 8. And this one is contradiction. For this case, if m squared minus n squared plus 1 is 10. So it will be 9, so it will be 8. 8, so n is 1 by considering this case. N is 1, so if you replace m squared is 12, and again contradiction. For this one, if we check m squared minus n squared, if it is 16, m squared minus n squared plus 1 will be 18. Again, contradiction. If this one is 16, then this one is 14. Again, contradiction. If this one is 20, then this one will be 22, contradiction. If this one is 20, then this one will be 18, contradiction. For 42n, if you had question about the solution here or any other solution, any problem, as I said, feel free to send message to my WhatsApp number in the description and comments. Here it is 40, so it will be 42. Okay, so for the first case is n is 23. If it is 40, it will be 38, and will be what? 19. Now here, okay, so let's check it again. If it is 40, it will be 42 it will be 21. Sorry, 21. If this is 40, it will be 38, 19. Now for the first case, you say, okay, m squared minus n squared, and n squared is what? 21 squared, minus 1 is 40, so it is 41. So m squared is 441 plus 445, contradiction for this one. M squared, here we've considered that this one is 40. So if this one is 40, m squared minus 19 squared plus 1 is 40. Let's check it again. Sorry. M squared minus n squared here is minus 21 squared. Minus 1 is 40 squared. Let me correct this part. Minus this 40 squared plus 1. So it will be 161. It will be 441. And m squared for this case will be 0. 4 minus 10, 6. 4 minus 5, 1. This one. Sorry again here. It is 40 exactly, not 40 squared. So it will be, let me correct it. It will be 41. And if we add up these numbers, m squared equals 41 plus this 482. And it is not perfect square for this one. M squared minus 19 squared plus 1 equals 40. And it will be minus 360. So m will be 20 for this case. Now m20. So here we found mn is what? 380. So for this one, it is this. Let's consider the last case. In the last case, if this is 80, then it is n. If it is 80, then it is 82. Then n is 82. It's the first case. The second case, if this is 80, then it is 78. So let's consider at first this case. M squared minus 82 squared minus 1 is 80. This case, m squared, let me write here, m squared minus 78 squared minus 1 is 80 here plus 1, if it is 80. So from first one, m squared equals 80 plus 82 squared plus 1. For this one, m squared equals 80 plus 78 squared and minus 1. We know it is greater than 78. Also, m is greater than 78 squared, so I consider m is greater than 78. Here also I consider m is greater than 82 because it is greater than 82 squared. So 82 times this, it is greater than this because we want to find minimum. Meaning smallest possible value. So we don't need to check is m is perfect square or not. So our answer, mn, minimum mn, smallest mn equals 380. SMO 2020 junior section first round problem number 25. What's the value of this term? So if we write the first one like this, 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 to 1 over 35 plus 1 over 36 plus 1 over 37. Then the next line is start from here. 2 over 3, 2 over 4, 2 over 5. And to 2 over 35. 2 over 36 plus 2 over 37, 3 over 4, 3 over 5, 3 over 35, 3 over 36, 3 over 37. And if you write until the last one here, 35 over 36 plus 35 over 37, and this one 36 over 37. And if you consider the columns, the first column will be 1 over 2, the next column will be 1 over 3 plus 2 over 3, the third column will be 1 over 4 plus, we consider it somehow double counting. For example, instead of rows, we consider the columns. If you want to know how double counting works or other problems, if you had any question, as I said before, feel free to send message to my WhatsApp number in the description and comments. So it's 36 over 37. Now, here we say, okay, for the first one is 1 over 2. Let me write with sigma. It will be, okay, it will be sigma k from 1 plus 2 to k minus 1 over k. K is from 2 to 37. And it will be what? K times k from 2 to 37. K times k minus 1 over 2. If you cancel k, it will be k minus 1 over 2. And it will be what? 1 half 1 plus 2 to 36. And if we add up all these numbers, it will be 1 over 2 times 36 times 37 over 2. We divide these two. Okay, so we have 9 here. 9 times 7, 63. 6. 9 times 3, 27. Plus 6, 333. Okay, I released SMO 2021 for open section, junior section, and senior section. For 2021, also I'm releasing for 2020. I will release for 2019 and other years. Also, I will release for other rounds, other Olympiads like AME, AMC for USA Mathematical Olympiad, for BMO British Mathematical Olympiad. If you want to learn the ideas, if you had any question, feel free, as I said, to send message to my WhatsApp number in the description and comments. Also, subscribe my YouTube channel, turn on the bell to have next videos and improve your problem solving.